Problem name is possible bipartition. So the question is, we want to split a group of n people labeled from 1 to n into two groups of any size. Each person may dislike some other people and they should not go into some same group. So we have to split 1 to n numbers in two groups in such a way that if two person dislike each other, then they should keep in different groups, not in same group. So we have given an integer n and an array dislikes, where dislike of I is a of I and b of I, indicates that the person labeled ai does not like the person labeled bi. Return true if it is possible to split everyone into two groups. Okay, so we have given this n equal to 4 and dislike is this. So now n is 4 and dislike is 1 dislikes 2. So 1 dislikes 2, 1 dislikes 3 and 2 dislikes 4. 1 dislikes 3 and 2 dislikes 4. It is a graph problem. So I'm representing this dislikes in this such in this way, that one is, it is just kind of, one is connected to two. The one, there is one age in 1 and 2, and then there is one age in 1 and 3, and there is one age in 2 and 4. So 1 dislikes 2, 1 dislikes 3 and 2 dislikes 4. So we have to split this whole numbers in two groups in such a way that two person whoever dislikes each other should be kept in different groups. So it's a kind of, if you have heard m coloring problem, so it is kind of two coloring problem. It is kind of two coloring problem. Like here we have given this question, so we will solve this question. Okay, so we will start from one. What we have to do, or like initially what you will do, you will see if it is not colored. It is we are solving this problem from m coloring problem. Okay, so m coloring problem, you will get to know. Just stay with me. Okay, so first I'll say if it is not colored, color it with any color, like I'm choosing red. So I will say if it is not colored, color it with red. Okay, now I will move ahead with its adjacent. Okay, I am at 2. Let's say I am at 2. Okay, I am at 2. I will check if it is not colored. If it is colored, first I will say there are two conditions: it is colored or it is not colored. Okay, if it is colored, I will check if its color is matching with this color. Like there is two condition: 2 is colored or not colored. If it is colored, I will check it is its color is matching with its parent or not. Its color, two's color is matching with one or not. Two's color is matching with one or not. So if it is matching, then what we say? We say we can't we can't group we can't group them together in such a way that two person who dislikes each other can kept in other groups, can kept in different groups. And if it is colored, but its color is not matching with one, its color is not matching with adjacent, its parent, then we say okay, it is not matching, so we go forward, we go in its adjacent. Now if it is not colored, we say color it with different color, color it with different color, another color. Two color we'll take. We are taking red and this purple. So if it is not colored, I'm saying if it is not colored, I will color it with purple. Okay. Now I will go in. I am solving this from DFS. So I will go in its adjacent. Its adjacent is 1 and 4. Okay, so I am going to 1. If it is colored, if it is colored, if it is colored already, means I have checked it, no? If it is colored, I will say if it is matching with, is this matching with it? The one's color is matching with 2. If it is not, then go forward. Or or I can say if it is colored, then go in another number. Then go to another adjacent. 2's adjacent are 1 and 4. If I have colored some number, means I have checked all of its adjacent. If I have colored one number, then I have checked all of its adjacent. So I don't have to check one again. I don't have to check one again from 2. So if one is colored already, I will say go to next adjacent. Go to next adjacent. So I am at 4. It is colored. No, it is not colored. I will say color it with different color, means red, another color. Okay. Now go to its adjacent. Is it containing any adjacent? No, it is not containing. We will return. We will return to 2. Is there any adjacent of 2 left? No. We will return to 1. Okay. Is there any adjacent left? Yes, 3 is left. So what I will say? I will say 3 is colored or not. 3 is not colored. I will say okay. Color it with different color. Color it with its parent's color. If is its parent color is red, color it with another one color. If its parent color is purple, color it with another color. So okay. Is any condition is violating? No. One hates. Okay, now I have grouped 1 and 4 in one group and 2 and 3 in another group. Is it violating other our condition? No, because 1 hates 3. Okay, they are in different group. 2 hates 4. Okay, they are in different group. 1 hates 2. Okay, they are in different group. So we can group them together. We can uh, one more example you can see. One is 1 2 1 3 2 3. Okay, so what I am doing, first I will check if it is not colored, color it with any color. I am taking red color. Okay, go to its adjacent. I am going at 2. I am going at 2. Okay, so is it colored? No, it is not colored. Color it with different color. I have colored. Okay, go to 2's adjacent now. I have gone. Is it colored? It is not colored. Color it with different color. I have colored. Okay. Now go to 3's adjacent. 3 is okay. For 2, I have gone to 2. For 1's adjacent, I am gone to 2. For 2's adjacent are 1 and 4. 1 and 4. So 1 is already colored and its color is different with 2. So I'll say okay, continue. Now I am at 1 and 3, sorry. 1 and 3. Now I am at 3. So I have colored. It is not colored. So I have colored it with different color from its parent. Okay. Now I am at 3. 3's adjacent are 2 and 1. 3's adjacent are 2 and 1. I will check 2. 2 is colored. Okay. And its color is different from 3. I will say continue. Continue. Now its next adjacent is 1. I will go to 1. Is it colored? Yes, it is colored. Its color is different from 3. No, its color its color is not different with 3. It is matching with 3. If it is matching, I will say return true or false. Any condition I can take. I will say it return true means it is matching. I will say it is matching, return true. So what I have to check, I have to first I will make this graph, and for every node, from every node, if because some of the example the graph can be not connected. Here the graph is connected. Okay, here graph is connected. If here n is 4, if here n is 4, so 4 can be here. This graph can contain two component. So we have to check from 1 to n. We have to check from 1 to n. We will run a we will we will write a function dfs, and we will call a function function dfs. If this function return true, if they are matching, so I will return their true. So if this function is return true for any node, I will say we can't color this graph or this, we can't group, we can't we can't, sorry, so we can't group pupils, we can't group pupils in different group if it is not returning anywhere true. So I will say return, so I will say we can group the person, we can split the group, we can split the group in two different groups. Sorry for disturbance. Okay, so here I am taking an adjacent, here I am taking one vector of it adj for making the graph, for making this graph. So I'll say and one color to keep track of these nodes color. Okay, so I'm just making this graph. Now for every node from 1 to n, I am checking if it is not colored. Okay, call the dfs. If this dfs is returning true, means they are matching, two adjacent are matching, so I will say return false, means I can't split the group. If it is any, for any node it is not returning true, so I will say here it is not returning true means they are not matching, so I'll say return true, we can't split them. Now this is the dfs. So what I have done, if it is not colored, if the node is not colored, color it with some color. So let's say I am using there I am using red, here I am using 1. So if it is not colored, color it with 1. Now go to its adjacent. If I have colored some node from 1, then its adjacent I will color it with another color, means I am taking here 0. I am taking here 0. Like if I am going to its adjacent, if this adjacent color of x is -1, means it is not colored. If it is not colored, I will say color it with different color it with 1 minus its parent color, means whatever its parent color is there, if it is 0, then color it with 1. 1 minus 0 is 1. If it is 1, then color it with 1 minus 1 0, opposite color. So if this dfs is returning true, now I will call for its child's adjacent, so it will call again. So if anywhere it is dfs is returning true, return true. True means they are matching, here I am returning true for matching. Else if if is, if it is not colored, if it is colored, so I will check if the child color is equal to parent color. If child color is equal to parent color, I will say return true, means they are matching, so this will return true. If this will return true, here I will return false. If this whole for loop and calls will will finish, then at last I will say return false. No two adjacent are coloring with same color, so return false. If it is returning false for every node, I will say I can split, so at last I will say return true. So I can submit. It is running.